Hi, I'm Ryan Flaherty with the SMTA, and this is SMTA TV. Today I've got Rob Boguski joining me. He's the owner of Datest. And Rob, I understand, I know the word test is in the name, so am I on the right track?
You're on the right track, Ryan. Although testing, as our company does it, has evolved over the 35 years of our existence. We started in 1984 as strictly an in-circuit test development, hardware and software development company. And as the needs and requirements of the industry have evolved over the years, we've added many additional capabilities having to do not only with direct electrical testing, but also with things having to do with failure analysis, where the customer not only wants you to write a program and maybe develop a fixture to test a board, but once you've tested the board, if it fails, determine the nature of the failure. What is the root cause? Is it a solder joint defect? Is it a bare board problem? Is it some sort of a workmanship error? So the value add that we provide nowadays often has a lot more to do with, okay, you diagnosed, you determined it failed, great, but what are you going to do about it? And a good portion of our business now has to do with ascertaining and narrowing down what the root causes are.
Right. Well, that's great. Are you guys noticing any trends, a lot of the same problems coming in, or other things based on new technology, new designs? That
the challenge for us is always coping with miniaturization.
Okay.
In the old days when we 80s level technology for in-circuit testing presupposed that you had dedicated test points for every net or network on a board that you wish to test. Nowadays, with miniaturization, packaging densities, and so forth, in products such as cell phones and all the other miniature products that are out there, you can't always drop a probe on every test point, and in fact, often you don't even have a test point to begin with. Right. So you have to use a lot of additional methodologies that have developed over the last 30 years. Flying probe is a good example of that. Boundary scan is another good example of that, which is a virtual test technique where you attach power and signals to one end of the board, and you send and receive signals through the board and take measurements of those signals, and based on that and based on the software that you're using, you can determine whether you have shorts and opens embedded in the board.
Nice. Wow. It's starting to remind me of the test guidelines that we publish, and I'm like, boundary scan, oh God, these words are sounding familiar.
We actually use those test guidelines. Yeah. That's our starting point. When a customer wants help, I'm in the design phase, and what can I use as kind of a baseline set of guidelines? We usually pull that out and direct them to the SMTA website and say, here's where you need to go. It's not going to answer every question that you may have, but it provides you with some fundamental design rules to start with, and you can build those into your design. The unfortunate reality, however, is that 80% of the designs that we get, it's a done deal.
Right. Yeah.
And we haven't had the opportunity to provide feedback. We just have to accept what we're given and adapt the technologies and the methodologies that we have to the board at hand. So what that means is often you can't test 100% of the board, maybe you only test 85% of the board. Right. But that's often the way it is.
It's the nature of the beast, I guess.
It's the nature of the beast, and it's the reality that we have to live with. What has also evolved in the last 10, maybe 15 years is inspection technologies have gotten a lot more sophisticated. So now we don't only do electrical testing, but we also use things like X-rays, two-dimensional, three-dimensional. We also use CT scanning techniques to dig into a board non-destructively, which is really important because if you're making a $30,000 blade server board, you don't want to tear that thing apart for obvious reasons. So if a technique exists where you can image that board and find out that BGA has a hidden pillow defect or a micro crack on it, you can do something about it. You can remove it, you can replace it, and put it back in service at minimal cost and disruption, rather than having to use the old technique, which was to cut it up completely and sacrifice that board.
Right. And if the customers can't afford a brand new machine, you guys have them, right?
Precisely.
And you do that work.
We've spent the money,
right? Yeah.
So they don't have to.
Yeah, exactly.
We have some very expensive machines, particularly in X-ray. We have 4 machines currently to do that sort of thing, depending on the size of the product we're looking at, its complexity, length, width, weight, material density, and so forth. What's also happened in our business is, besides electronics, besides just boards, the technologies enable you to look at other things. So, especially in the CT scanning world, we now inspect all kinds of materials.
Right.
We look at metals, we look at plastics, we look at liquids in some cases. We look at tubular structures, we look at space flight hardware. All of it non-destructively. That's the common denominator. So you have a little box that maybe costs $15,000. You don't have to tear it apart. For a fraction of that money, we can scan it and hopefully pinpoint the root cause of why it's stopping, why it's failing to work.
That's excellent. Well, thanks for sharing that with me, and thanks for sharing that with us here at SMTA and SMTA TV. So appreciate it, and we'll talk to you soon.
Thanks for the opportunity.